Hello, this is the luckiest maths teacher in the world. Today we're going to learn Bidmas, but before we do that, I'm going to let you in on a little secret. I am not who you think I am. In addition to being the luckiest maths teacher in the world, I'm actually a superhero crime fighter. That's me, the muscly, beautiful, blue-eyed boy you see on the screen. I protect you at night. Now, there's somebody who's getting under my skin. All he ever wants to do is take me down. I'm sure you've probably met people like that. The person who's annoying me is this guy here, the villain of bad calculations. Look at him, looking all evil like. See, every day he tries to wreak havoc on Canberra. But Canberra being my turf, I sort him out. But to do this, I'm going to let you in on another little secret you can't tell anyone. I need certain supplements, certain things to help me so I can defeat the villain of bad calculations. So you're going to help me go shopping. So every night I need a couple of these. I need 2 of these chocolate bars. Now, superhero can't just eat chocolate. I also need something to drink. I have this special potion, which is how I get to be so muscly and have such beautiful blue eyes. See, I need these things to survive, to save you from the villain of bad calculations. Now, unfortunately for me, us teachers, because we do it for the love, we don't get paid a whole lot. See, every week, you know how much I get paid? Guess, only this much, only $10. That's all I have this week. But it's vital that I get my 2 chocolate bars and my potion, because otherwise I can't save you from the villain of bad calculations. Now, fortunately for me, $10 is, well, usually enough. See, these chocolate bars, they only cost $2 each. There you go, $2 nutrition. Now, the potion, it's a bit more expensive, but hey, I'm willing to pay for it. It makes me strong. It's $5. Pretty simple, isn't it? I have enough money, don't I? The reason I have enough money, bear with me, is that $2 plus $2 plus $5 is $9. So I should have enough, and I should even get a whole dollar change. I could buy another half a chocolate bar. But you see, this is what happened. The villain of bad calculations tries to trick me. He takes the form of the beautiful checkout girl. Now, when we're adding up how much I have to pay, you can write it another way. You don't have to write 2 plus 2 plus 5. You can write 2 lots of, which is times 2 times 2 plus 5. That's how much I have to pay. Now, what the villain of bad calculations does, because he knows he can't take on the amazing lucky maths teacher, he tries to tell me that we actually do the addition first. He says I have to pay 2 times 2 plus 5. So he's saying that I have to pay 2 times 7, which is $14, okay? If that happens, I don't have enough money. I can't get the 2 chocolate plus the plus the potion, and you guys are all going to die. See, this is what happens when people use calculations wrong. See, maths can save lives. Fortunately for me, I listened in maths class, so I was able to convince him, rather forcefully, that even though he's right, even though you can write how much I pay as 2 times 2 plus 5, actually, what I have to do is the multiplication first. So this isn't 2 times 7, it's actually 4 plus 5, which is, of course, $9, not $14. So, lucky for you, I can afford it. Now, there's a few things I really want you to learn out of this. Number 1, your maths teacher is an amazing superhero, and number 2, maths saves lives. Both of them are very, very important. You see, what I've just explained to you is why we actually do multiplication before addition. So you know as well as I do that it doesn't matter the order in which we add things up. So I could have bought the chocolate bar, then the potion, and then the chocolate bar. I know that it should have cost me $9 all up. However, I can rewrite this as I said, 2 lots of 2 plus 5. If I do the addition first, we get an answer of 14, and that's not the common sense answer. You'd end up having to pay $14 for your 2 chocolates and potion. And that doesn't make any sense. It doesn't agree with our answer here. That's why we have to do multiplication first. So we get the same answer, 2 times 2 plus 5. So, similar to this, there's a whole hierarchy for how we order operations. We must do them in a certain order so that everybody gets the same answer. So that if you're a wonderful superhero like me and you decide you need some fuel from the supermarket, it won't cost you $14 one day and $9 the next. So, what is this set of rules to which I refer? And the answer is Bidmas. Some of you may have called this Brodmas, you may have heard of PEMDAS, BODMAS. They're all pretty much the same, but I'm going to go Bidmas. I think that's the easiest one to understand. So what do all these things stand for? Well, pretty simple. B stands for brackets. I stands for indices. Remember from a few lessons ago, indices, powers, and exponents are all the same thing. So that's raising to a power. So we do anything in the brackets first, then indices, then now even though division and multiplication are listed one under the other, these are sort of equal, if you like. They sort of have the same importance. So you do whichever is first, left to right. And I'll go through some examples of that. Similarly, addition and subtraction are kind of the same rank. So we do whichever comes first from left to right. What I suggest you do is write this down in your book. You can pause the video so that you can refer to this every time we do a question. I'm now going to go through a few questions. Okay. So, let's start with an easy one. 3 plus 4 times 5. So what we do is we go down our list here. There's no brackets, no indices, there's no division, there's a multiplication, and there's an addition. Because multiplication comes first before addition, even though the addition sign is first in this sum, we must do the multiplication first. This is how I want you to set it out. So I want you to show the steps that you've taken. So the next step, the answer would be 3 plus, now 4 times 5 is 20. We didn't do anything with this 3, which is why I wrote it down here. It's still there, it doesn't go away. The answer is then, of course, 23. Notice how my equal signs are underneath each other. That's the kind of setting out I want to see. Let's do another one. So let's say I was given 16 times 2 divided by 8. Now, the order of operations here is important. Now, although multiplication is below division, as I said, they rank as the same importance. So we do whichever one comes first, left to right. So left to right, here we see that the times is first. So 16 times 2 is 32. We haven't done anything with the 8. We leave it as it is. 32 divided by 8 is 4. Our answer is 4. Now, notice if we actually did the division first, we'd get exactly the same answer because 2 divided by 8 is a quarter and 16 times a quarter is 4. But that isn't always the case. So I'll give you an example where we'd get a different answer if we got the division and multiplication the wrong way round. So let's look at this one I've just put up, 18 divided by 2 times 3. If you do the multiplication first, 2 times 3 is 6, you get 18 divided by 6 is 3. If you do it the right way though, because division occurs first from left to right, if you do that first, you get 18 divided by 2, which is 9, times 3, which is 27. Okay? So, let's just make sure we're following this here. Alright, I'll give you another example. So let's look at this one here. It has brackets and an index. So notice we have a multiplication. Now normally multiplication, as you can see from our chart, is before subtraction. But because of the brackets, we actually do the subtraction first. That's why we have brackets. Sometimes you do want to do addition or subtraction first. Sometimes you need to. So this one here, we leaving the 4 alone for now, times, so 6 minus 5 is 1, and we have it to the power of 3. Now, what we do now is the power, the index. We need to do that first because we've got a times and an index. Indices comes before multiplication. So this isn't 4 times 1 is 4 and 4 cubed is 64. We leave the 4 alone. 1 cubed is just 1. It's 1 times 1 times 1. So the answer is 4. Okay, now I'm just going to show you one more type of question. So copy this down if you need to. You can pause the video. So this is a kind of question you'll get. You'll be given an equation that's not true and you'll have to insert brackets so it is true. So let's just look at what the equation says now. So normally what we have to do is, if we were given 4 plus 6 times 3 minus 9, we'd have to do this first because multiplication occurs before addition or subtraction. So what we would do is we would go 4 plus 6 times 3 is 18 minus 9. So then addition and subtraction, remember we do them in order which occurs first from left to right. 4 plus 18 is 22, minus 9 is 13. So that's why the blue brackets, the blue equation is just completely wrong, and that's why it needs brackets. So let's get rid of the red. So we need to make this left-hand side, the 4 plus 6 times 3 minus 9, we need to actually make it equal 21. Now this isn't as hard as it looks. There aren't that many places the brackets can go and make a difference. For example, if I were to put brackets around the 6 and the 3, that doesn't actually change anything because I was going to do multiplication first anyway. The only places I can put them to change it are around the 4 and the 6 or around the 3 and the 9. There aren't that many options. So what happens if I change it by putting brackets around the 4 and the 6? I end up with brackets 4 plus 6 times 3 minus 9. Now, of course, that equals, we do the brackets first now, 10 times 3 minus 9. We've now got multiplication and subtraction. Of course, we do multiplication first. So 10 times 3 is 30 minus 9. That equals 21. Okay, so if I put brackets around the 4 and the 6, I make this statement true. As I said, there weren't that many places for me to put them. Alright, that about wraps it up. This has been the luckiest maths teacher in the world, who is also a wonderful crime-fighting hero, and I hope you have a great day.